Okay, let's go ahead and get started. On Friday, we talked about being a client of lists and sets, and we're going to talk about being a client of other data structures in the Wednesday lecture. That's, it's in your next, in homework 2, homework assignment, you're going to be a client instead of implementing. But we have kind of an extra lecture that we get to fit in here. So what I'm going to do today is go back to what we were working on before, which is kind of looking at the array int list class. Now I told you that everything that you need for the homework we finished last Wednesday. So this is just reinforcing those ideas. This isn't any of the stuff that's new today. It's not stuff that you're going to need for the homework 1. But it's basically giving you a better understanding. I've mentioned that array int list is a case study that I use throughout the quarter, and I kind of try to slowly but surely evolve it, so that it gets closer and closer to the built-in array list of E class. All right, before we begin with that, we have our question of the day last time, had to do with operating system. I was surprised. I thought actually Mac would be a little bit higher than that, but that was kind of interesting in terms of what people use. Not very many people using Linux. Okay, so let's switch to, maybe I'll also just mention in terms of general class stuff. I sent message last week about applying for the honors section. There were some people who didn't sign up correctly, and I've given them a little extra time to sign up. So I've actually extended the deadline until today at 3 o'clock if you want to sign up for the honors section. So you can click on this link to read about it. You've got till 3 o'clock today to fill out the Catalyst form that's on that page if you're interested in having me consider you for the honors section. We're going to have our first meeting this week on Thursday. And in terms of, let me just a reminder that under the Zoom links tab, there are office hour links for the TAs. So if you need any help with anything, go to the office hour links to find out who is on duty. Okay, so let's switch to JGrasp. So this was the version that we finished with at the end of Wednesday's lecture. Let me mention a few things that are going on here. 2 different constructors. There were 2 versions of the add command, the appending add and the add at an index. I did want to mention something that I mentioned in my 142 class, but we didn't spend a lot of time on it. It's possible people have forgotten. It's also possible that you didn't hear about it in your own class. But I wanted to mention something that's going on here because I often have students ask me about this, that we have an add command here and an add command here. How come they're both called add? And so this is something that's known as overloading. So you are allowed to have 2 or more methods of the same name if they have different signatures. So in general, the signature for a method is its name. So obviously you have 2 methods have different names, then they have a different signature, but they can have the same name. The name and the number and types of parameters. So what's going on here is Java says, well, the signature of this add method is that it takes 1 parameter of type int. The signature of this add method is that it takes 2 parameters, both of type int. So, this one you describe as add of int. This one is add of int comma int. So those are different signatures, and that's why you can have more than one version of it. In fact, if you were to read the internal documentation about a command like print or println, you'd find that there's tons of different versions of println. One that takes an int, one that takes a double, one that takes a Boolean, one that takes a string, lots of different versions. So you're allowed to do that overloading. That's what's going on with the constructor as well, by the way, is that we have an overloaded constructor, one of which its signature is 0 parameters, and the other one's signature is a single int. So that's how Java distinguishes between them. So this version, we had a size method, we had a get method to string. There was an index of and a contains method that we wrote for this one. The 2 add methods, the appending and the add at an index. There was removing at an index. and then there was an add all that we did as an example. Now, I mentioned something at the end of the lecture on Wednesday, but it went a little quickly, so maybe I'll just kind of repeat what's going on there. So this version, so one of the things that's going on with this version is that if you look at something like the get command, the get command is supposed to look at the value of that index and throw an exception if that's an illegal index. And what I found is that I had the same code in the get method as I had in several other kinds of methods. So remove, for example, had the exact same code in it. And I mentioned that what I did with that code is that I made a separate method called checkIndex that had that code for checking the index and throwing an exception. We've been trying to train you since the beginning of 142 to eliminate redundancy. So when you have the same code appearing more than once in your program, it's good to put that into a separate method. But there's this issue that comes up. Last time we were talking about this idea of an API, and I've mentioned that this is the Java API documentation that I have on the links page, and it even describes it that way, right? The Java Platform API specification, the application programming interface or program interface. It's basically if a programmer is going to be writing an application in Java, how are they interfacing with these different kinds of objects that you have here? So there's a kind of an English-like description of it, a set of method headers and so forth. We looked, for example, at the, let's bring up the list one, the list interface. So this kind of was a description of, there's an English-like description of what a list is supposed to do, kind of the behaviors of a list, and then a list of various methods here. But the API for list does not say how it's implemented. So we don't know whether that's done with an array, whether that's done with what's called a linked list, or whether it's done in some completely different way. So all we know is kind of this high-level abstract description of what's going on with a list and what are its methods. Well, when I give you a programming assignment, so like I gave you homework 1, I give you a kind of API, so like there'll be a table that has a bunch of different methods that you are to implement with a description of what the different methods do. So that's a lot like this description here. And then there'll be, paragraphs where I describe various other things about what you're supposed to do. So I'm kind of specifying for you, the API for this class that you're developing, this class of objects that you're going to be writing the code for. And so I list a whole bunch of methods that I want to have be public methods. And one of the style issues, I mentioned this last week, but I'm just reminding you, you are not allowed to add extra public methods to what I have asked you to do. So I give you a list of public methods I want you to do. If you introduce extra public methods, that's a style error. So I asked you to do a specific, API. You shouldn't be extending it. You shouldn't be adding extra things to the API. The main point of that was that, so if you wanted something like a check index method, you're allowed to create as many methods as you want, but they should be declared private. And by having it be private, it's not visible to the client. So therefore, you're not extending the API. You're not kind of making something extra available to a client that wasn't there before. So you can have as many extra methods as you want, just make them private methods. I tell you what I want you to do that are public methods, and then you can introduce your own private methods. I think I also mentioned this last time. Maybe looking, add is not such a bad one to look at. When you write the add in an index method, it needs to have enough space to increase the list size by 1. And you'll notice that there's a little call here on a method, check capacity. So what I'm doing here is I'm making sure that there's enough room to add one more thing. In the add all method, let's see, we could take a peek there. Here it's checking the capacity and it's making sure that there's enough room. You're adding everything from the other list. So if the other list had 8 things, you want to make sure that you have an extra 8 spots in terms of capacity. So what this version did, the one that I gave you on Wednesday last week, is that it checks to make sure that you never exceed the capacity. So it's not going to have an error where it tries to add things beyond the end of the array, because it always checks before it does any kind of an addition to the structure. So that was the solution we did for last Wednesday, was that it kind of checked the capacity and it threw an exception if the command you've asked it to do would exceed the underlying capacity of the structure. Okay, so that's kind of a review of what we had done. I want to add several things to this today. Maybe, how about if we'll go up here a little bit, because I want to do kind of a couple of fairly basic methods. So we had a get method, we had the adding methods, the remove method, and so forth. There's some methods that are missing, and actually, if you are paying a lot of attention in Friday's lecture, where we did array list, you might be able to figure out what is it that we haven't yet included in our array int list that we had in array list. Well, and there's a couple of these methods. This is great when I have an audience. It's great to get suggestions. I don't have an audience today, so I'll just kind of tell you. A couple of things that are missing there. I had mentioned this in Friday's lecture, that there's a method called set. So that takes an index and a value, and it sets the value at that particular index to that value. And I had mentioned in Friday's lecture that this is, it can be important in terms of efficiency. Like, what if you had 1 million things in your list and you wanted to change what's at the front? You know, without the set command, your alternative would be to do a remove at the front, which shifts 999,999 things, you know, down by 1, and then you could add back in at index 0 and it would shift it all back up again. So the set command can be important in terms of trying to make things be efficient. The set command does not add or remove anything, it just changes something at an existing index. And so we would say element data of index is assigned to this value, and here we are accessing a value of the element data. We want to make sure that that's a legal index. Turns out this is yet another place where check index does the right thing, so we can kind of call our private method that does that check. We'd want to comment on that. Remember that you have to comment all exceptions that are thrown, the conditions under which it's thrown, and the exact kind of exception. So we'd have to have something like this in the documentation. You'll see that in what I post later today for this new version of array int list. Another thing that's in the built-in array list class that's a nice thing to have is a method called clear. Now, clear is just supposed to empty out the structure. And so if you had, say, 1 million things stored in a list like this, our only alternative right now is to go remove, you know, over and over again until it becomes empty. So it's nice to have a method like clear that just does it very quickly, because the remove commands are going to shift things, you know, so they're, you know, or even if you do it from, you know, it's better to do it from the end, but it's still a whole lot of remove calls that you have to make, you know, when this can be done very quickly. If we reset the size to be 0, that just kind of puts it back to being empty. So that's kind of a nice command to have as well, is the clear command. So I'll include set in clear in the version that I'm going to post for today. Again, we're trying to get closer to a version that's like array list. And I want to do another one with you that's kind of interesting. I mentioned how we are reviewing arrays and classes in these first 2 weeks. And this is there's an interesting task that I want us to do that it's in effect, you know, going to let us review a little bit about array style reasoning. So there's a method called addAll that we wrote last Wednesday. I want to write a method called removeAll that takes an array int list other. And so the idea here is that it removes all occurrences of values from this list that are in the other list. You know, I could probably word that better, and I think I probably did word it better in the version that I'm going to post later today. But the idea is that this other list has some things in it, and you know, a sequence of values, and we want to remove all of those from our list. There's an idea that a lot of people mention in object-oriented programming, and I'm a fan of this idea too, that you should anthropomorphize your objects. You should think of your objects as being like people. So, I've even seen students do this where it's kind of like, okay, wait, to try to figure this out, why don't I be the list that's being talked to, and you be other, so that we can kind of have two people, so what's the idea of removeAll? Well, you've got some things in your list, and so what I'm supposed to do is I'm supposed to make sure that anything that's in my list that's also in your list gets removed. So all of the things in my list that are in your list are going to be removed. So how do we do that? This is, again, it's too bad. I love having the audience participation on this to have you give suggestions about how to do this. Let's think about it in a pseudocode way first. And the interesting thing is that I almost always get the same suggestion about how to approach this. Well, maybe it kind of makes sense that you're being given this other list, and those are the values that you need to pay attention to get rid of them from my list. So what students normally suggest is some kind of a loop that's kind of for all the values in the other list. That's kind of the people just seem to think of the problem, the solution in that way, is that they kind of imagine that's the right way to go. Well, what would you do? So suppose so you're the other list, and in your list, the first thing on your list is a 7. So that means I'm supposed to get rid of all of the occurrences of 7 in my list. Well, so what does that mean? So that means I have to kind of do something like for all the values in my list, so I kind of have to go through all the things in my list, and if the values are equal, so if I find a 7, I go through all the things in my list, oh, there's a 7, then remove it, would be kind of the approach we'd be doing here with this approach, this pseudocode. This is not the way that I want to solve the problem. There's a kind of, there are different reasons you might give for approaching it one way or approaching it another way. Let me give you some examples of where this could be inefficient. What if the other list, so I said, what if it had a 7 at the front? What if it has 18 occurrences of a 7? Then basically what I'm going to do is I'm going to remove a 7. I'm going to go through my entire list looking for 7s and getting rid of them. But the first time I do that, they're all gone. But now you got a bunch of other occurrences of a 7, and every single time I come across another 7 in your list, I have to go through my list again and again and again and again. So that can be somewhat tedious. There's also, I think, kind of a sense of, well, which list is likely to be bigger? And I think that the other list is likely to be shorter, that in general you might say, well, I want to get rid of some specific values. So that might be, a relatively short list. But so I don't want to have to kind of go through my list over and over and over again. There's another reason I think that's another reason why I like to do it in a different way, and that is that we have a method we can use called contains. So we wrote a method called contains. In any event, it can be written either way. So I'm not saying that it's wrong to write it this way, but I kind of prefer writing it in this other way. And it turns out that that's what the Java folks did when they went to write a version of this method. Is that instead of thinking of the for loop as being for all the things in the other list, they think of it as for all the values in this list. Let's leave this in, we're doing pseudocode, so let's leave this in comment form. Instead of looping over the other list, let's loop over our list. And then what would we say here? We would say if the next value is in the other list, then what would we do? So basically, I would go through my list, and if I came across, say, a 7, I'd say, is that in your list? Is that in the other list? And if it is, then I want to remove it. So that's kind of the way that I wanted to write it. And one of the things about that is that asking whether it's in the other list, I can call contains. So that's kind of a nice use of a method that we've already written. So this is the way that I want to write the code initially. So let me go ahead and comment that out. So let's try to write this code. For all the values in this list, we have an array called element data, right? We know how to do a standard traversal over array for int I equals 0, I less than. Now in the standard traversal, we do element data dot length, but remember we don't go all the way to the end of the array because it's not necessarily full. We don't want to. We only want to go up to size. So because there might only be 3 things being used out of 100, for example. I plus plus. And so then element data of I is kind of that next thing. So what do we want to do with element data of I? We want to know if it's in the other list. Well, this is a place where we can use that contains method. I can say if the other list contains element data of I, so if that is so, if other dot contains element data of I, then what is it that I want to do? I want to do a remove command from my list. So that would be something that I want to get rid of from my list. So I could say remove at I. Let me go ahead. It turns out that this approach has a bug. So let's just kind of take a look. So for all of the things in this list, if the other one contains this thing, we're going to remove it. Let me hit compile and make sure that what error did I introduce? Oh, I missed a right paren. Oh, okay, I needed to have an extra right paren here. Okay. And so I have a little program here called test remove all. And actually, let me just run it, and let's take a look at the output that it generates. So let me compile and run it. And what it's showing is that here is a list 1, that we want to be talking to, where we're going to tell it to remove various things. And what I'm asking it to remove are the even 1-digit numbers, 2, 4, 6, 8, other than 0. So I'm asking it to get rid of all of the occurrences of 2, 4, 6, 8. So there's a bunch of occurrences of 2, 4, 6, 8 in this. And what I'm doing in my code is I'm setting up a couple of array int lists to work with, and a couple of array lists of integer that I want to work with. Oh, I don't know why this is an older version of this. I don't know why I didn't use the diamond operator there. I should have used the diamond operator. At least I'm using the interface type here to get the style points for that. In any event, our array int list should behave like array list of integer. So that's what we're trying to do, right? Is to get something that matches. So that was an easy way for me to be able to kind of test and see if it's working. I do a version of this using 2 array int lists, and I do a version of this using 2 array lists of integer. So I do the adding to these things, I do the calls on remove, and then it shows the original values that were here. So these were the original values. And then after the call on list1.removeAll list2, list1 has this and list2 is unchanged, which is good. List1 stores this sequence of values. But it's telling us, so it's got a little test in here where it compares the results and it lets you know what list1 should have had in it is this. If you get rid of the 2, 4, 6, 8 from this list, we should have been left with a 1, 3, 5, 3, 5. Instead, we're left with 1, 3, 5, 2, 3, 4, 4, 5. How come there's a 2 in here? How come there's 2 4s in here? Why are those in there when I was supposedly doing a remove all? So there's a bug. What we wrote here has a bug in it. And again, it's very nice to be able to get people to think about why would there be a bug. Well, if you wanted to, you could pause the video and kind of try to think through what happens as it goes through these various values. Because our list, goes through list 1. It looks at this one, and it says, is this in the other list? And if so, it removes it. A 1 is not in the other list, so it doesn't remove it. It encounters the 2, and that is in the other list. And so it does a remove of that one. When it encounters this 4, it removes it. And it kind of looks like those worked out okay. 1, 3, 5. So when we had 1, 2, 3, 4, 5, that became 1, 3, 5. So that kind of worked out. It got rid of the 2 and the 4. What's not working well is this sequence of values here. 2, 2, 3, 4, 4, 4, 4, 5, 6. That did not properly remove all of these different occurrences. Well, all right, let's talk about, I don't know if you've paused to think about it or whether you figured it out, but here's what's going on. When we get to this value right here, where there's a 2, so, and actually I think we will have gotten rid of the 2 and the 4 that were here. So we have 1, 3, 5, and then we have this value that's 2 here. But think about it when the I gets up to this spot in the array. It says, is that in the other list? And it is. So it does a remove. What does remove do? Remove takes all of these values and it shifts it down by 1. So this 2 that's in this spot right here is going to end up on this spot right here. It's going to get shifted onto this spot that already has a 2 on it. And then what are we going to do? We're going to come back around our for loop and we're going to increment I. So we're going to move past that spot. We're going to assume we already took care of what was here. Well, we did in the sense that we removed a 2, but we might shift some new thing onto that spot. So the thing is that we can't just do a simple if. I mean, you could imagine maybe there'd be a while or something like that, because while we're seeing things there and things get shifted, we do a remove. That gets pretty tricky. Actually, there's a simple fix to this. It's not a very elegant fix, but it works, is that you can just kind of say I minus minus. Look, if I'm removing at spot I know that something new is getting shifted onto that spot. And I know I'm about to do an I++. So I could do an I minus minus as a way of undoing that or kind of staying on this spot. It's going to kind of keep me here. So let me do a compile of this version and come back over here and run the code. And you can see that now we're getting the message that it passed. So that worked. I mean, it's showing you the final list here, 1, 3, 5, 3, 5. So that fixed the problem. The bug here was that without the I minus minus, then when there were 2 values in a row to be removed, it did the wrong thing. That's a good example of some of the kind of tricky things that come up when you're doing array-style problems. It's worth noting that there's another way of doing this, an interesting way of doing this, which is that instead of kind of going forwards like this and then having this problem of shifting, there's a kind of a programmer's trick that people know, which is oftentimes going backwards through a sequence of values, solves various problems. So if I started at size -1, because that's the highest index where there's an actual thing for my list that's stored there because of the zero-based. And then if I do not I less than size, but I greater than or equal to 0, and not I++, but I minus minus, if I go in the other direction, so if I start at the end and move towards the front, well then when it's doing a remove, the only things that get shifted are things that have already been processed. So the shifting is not going to cause a problem for us because it's to the right, of where we have yet to process things. So it doesn't affect the things that I have yet to process. So having it go backwards kind of is another way to fix this problem. Then we don't need that extra little I minus minus. Let me come back over here and run the code again just to show you that it says passed again. So that's another way of fixing it. Sometimes I spend the time to try to talk about a more efficient way to do this. Let me kind of see how it goes in terms of how long it takes to discuss the other stuff I want to do for today. So let me kind of shift gears and talk about that other stuff, and then we'll come back and I'll mention this at the very end. We may have time to talk about it, maybe we won't. Okay, so the next thing that I wanted to talk about is I wanted to say more about iterators. I gave an analogy in the Q&A on Friday that I've often used for iterators, and I'm going to give you even a second analogy. I can tell you that when I first came across iterators, I found them very confusing. So we looked at this code on Friday, this list set example. There was some code down here where we were going through a set. So we made an iterator that went over numbers 2, which was a set of numbers. And so we wrote typical kind of iterator code. While the iterator has something extra to show us, we get that next thing, and if it was a multiple of 3, we ask the iterator to remove it. So those are the 3 things that an iterator has. I had mentioned that, that there are 3 methods that an iterator is required to have: has, next, and remove. And those are included in an interface known as iterator of E. So here we're doing an iterator of integer. So what I found confusing was the iterators seem to have access to everything. So I found myself wondering, is the iterator a copy of the list? I mean, it seemed like it because it had access to everything. So one analogy that I give for this is that you probably have the same experience I have. You go to a pharmacy, you know that there's some prescription there for you that you're going to pick up, but they don't let and you kind of even get to know, right? Because you watch the different pharmacy staff, you know where they go to get those prescriptions. In a way, you could just go right there, find your prescription, and then go to the counter at the front or something to be able to pay. But they don't let you do that. Pharmacies are controlled, right? You got to stay behind some little booth that they have set up, and you have to ask the pharmacy technician to do that. So you say to the technician, I got a prescription for Regis, and then they go and they look it up, and they come back, and but in a way, you want to jump over and go and do it yourself. Well, that's a little bit like what's going on here. Is that there's a list. The list has lots of data in it. That's like the pharmacy. The pharmacy has all these drugs in it. It's a big thing that's got a lot of stuff stored in it. But you're not allowed to reach right in and access that. You're not allowed to kind of go past the barrier and go and grab your drugs directly. You have to work with this staff member, this pharmacy technician. And the pharmacy technician has the ability to access anything in the pharmacy. So they have an ability you don't have. That's why you got to talk to the pharmacy tech. And you kind of say, give me the prescriptions for Regis. They go look for it for you, and they bring it back to you. The pharmacy tech is like an iterator. It's the term that we use for that is that we call the iterator a lightweight object. It's a tiny object compared to the list itself. The key thing about it is that it does the accessing for us. It kind of deals with the pharmacy. But a pharmacy tech is not the pharmacy. I mean, this staff member has access to the pharmacy, but they aren't themselves the pharmacy. There's someone that we work with. This is, again, anthropomorphizing an object. Think of the iterator as being like this staff member that you work with to get you what you want. Another analogy that I thought might be an interesting one is to talk a little bit about how people do banking these days. So I bank my checking accounts with Chase Manhattan Bank, and I get checks every once in a while. And what I always used to do if I got a check is I'd go to a branch, of Chase Manhattan Bank. I would go to the bank in order to deposit my check. Probably most of you do what I do now, which is I don't go to the bank. That instead what you can do is you can pull out your cell phone, right? And there's an app that lets you connect to Chase Manhattan Bank, and it lets you take a picture of the check and say, deposit that for me. Well, what's going on with the cell phone? Has the cell phone become Chase Manhattan Bank? I mean, it lets you deposit a check. I mean, so it kind of seems to be doing what Chase Manhattan Bank does. Well, you know the answer to that. So no, it's not the bank, it's your phone. But the bank has been set up in such a way that I can have an object like this cell phone that's talking to the bank for me. So I talk to the cell phone. I take a picture of my check here that I want to deposit. I touch various buttons to give it the commands that I want to be doing a deposit, maybe enter the amount and so forth. And the cell phone talks to Chase Manhattan Bank. So the cell phone, again, is a lightweight object in that sense. It's not the bank. It's an object that talks to the bank. Well, that's what an iterator is. An iterator is an object that talks to a list for us. So basically, we create an iterator, and then we talk to the iterator, and the iterator talks to the list. And I think that this is something that is a useful exercise to actually understand how it's done. So if I came back out here and I took a look at H-I-J, you will find that there is an Iterator interface. So there's the Iterator of E interface and the mention of the different methods here. Has, next, next, and remove are the methods that we need to have. So what I want us to do is to think about how to create a public class array_int_list iterator. This is going to be an object, and so objects have to be of a type, right? There needs to be a class set aside that we can call in order to create these objects. Now, we're going to want this to be something that satisfies the Iterator of E interface. So I'm going to say more about this in Friday's lecture, but I'll just kind of let you know that what we need to say here is implements Iterator of integer is what we would have to say, is that this is going to be something that is that implements the Iterator interface. And remember, you can't say int, so we say integer. But you can kind of pretend it's ints because Java does auto-boxing, auto-unboxing for you. Another analogy for interfaces that can be a useful one is that I think it's a little bit like the way we use the word certification. You know, are you a certified teacher? Are you a certified nurse? Are you a certified accountant? You know, that the idea of certification is that we expect that you've been trained to be able to do certain things. That's a little bit like what an interface is like. In order for you to claim to implement the Iterator of E interface, you have to have those three methods. You have to have a has next, a next, and a remove. So you have to have a public Boolean method called has next. You're going to have to implement that. You're going to have a public integer method called next. I mean, we kind of want to say int, but again, because it's integer, we need to say integer. But Java's going to do the translation for us that we're going to be able to treat it as if it's returning an int. You know, all of the cases where we're writing code, it'll do the unboxing for us to give us the int that's inside. But for the header here, we have to say integer. So we need to implement that method. And we also need to have a method, public void remove. So those are the three methods that an iterator is supposed to have. Has next, next, and remove. So how do we do it? Remember with the list set example, I began by writing the standard traversal loop. So if you didn't have an iterator, if you were going to be the one who talked to the list, then what would you do? Well, you'd have an int I that you start at 0. You'd be comparing it against the size of the list. You'd be calling get. I mean, that's what we did when we didn't have an iterator, when we just did it ourselves. That was how we wrote the code. And this should kind of give you a clue about how we're going to write the iterator. I mean, what is controlling the access here? It's this int I. You know, we have an indexing variable that we start at 0 so that we're at the beginning of the list. We compare it against the size of the list to know whether to keep going. We make calls on get to get individual values. So it's this int I that I mean, that's really the core of what an iterator is a simple int, int I, this indexing int. So I'm going to set up a field here. I'm going to have a private int field. And I could call it I, right? To be like the for loop. But since it's a field, I want a better name for it. So I'm going to call it position. But I mean, it really is the int I. We're going to need to have an array int list iterator constructor, potentially, So let me kind of include some code here. I don't know what its parameters would be. And we would start position at 0. So, at its core, that's part of what we're doing. That's like saying for int I equals 0. There is an int I. It gets initialized to be 0. And how do we know whether something has a next value? Well, how did we test it here? We saw whether the I was less than list.size. So what are we going to want to do here? We're going to want to do a test where we see whether position is less than list.size. And that's a test, that's a Boolean test that returns true or false. We're going to want to return the Boolean value we get when we perform that test, when we see whether the position is less than list.size. So that's kind of the basic way we're going to write the hasNext method. But the question is, what's the list? So this is not the list class, and this is not client code. This is an iterator. This is the definition of some other kind of object. This would be like if we're trying to set up your cell phone, we're trying to write the app for your cell phone to be able to talk to Chase Manhattan Bank. Well, how is it going to talk to Chase Manhattan Bank? It has to have a connection. It has to know kind of who is it talking to. There's some object at the bank, that it's talking to. Here, which list are we talking to? Well, so what we're going to want to do is that when we set up our array int list iterator, we're going to want to tell it the array int list to talk to. We're going to say, we want you to talk to this array int list in order to solve this problem. And it then will have a field, private array int list, called list. I'm going to use the same name, list and list. I could use a different name, and then I wouldn't have to do what I'm about to do. But I kind of prefer, this is the more common Java convention, is to use the same name. Now, of course, you can't say list equals list. I want the field called list to be set to the parameter called list. Within this method, what's going on here, because I use the same name, this is what's known as shadowing. That inside of this method, list is the parameter here that's being passed. So in order to have this, in order for me to be saying set the field called list to that, I have to use the this notation. This.list is assigned to list. So the field called list, that's the way of referring to this thing instead. I want my field to be set to what the parameter is. So when you go to construct an iterator, an array int list iterator, you will tell it what list to iterate over. And that way it'll be able to do a hasNext. What about next? Whenever I've written the standard traversal, I've always kind of included a line of code here, where I've said that you do something with list.get of I. So it's list.get of I that kind of gets me my next value. So I can say int result is list.get of I. Not of I, but of position. Because we're using that field called position. And then remember that next was going to return you this next thing, so we will eventually return this result. But it also has to get you positioned one beyond. So as you call next, it's supposed to be moving forward. And how do we move forward when we're writing code like this? We do I++. So the equivalent here would be to do position to move forward. So that's basically how next is going to work, is that we're going to make a call on list.get at the position, increment the position, and then that's what we return. What about remove? So the way that remove was supposed to work is that it's supposed to remove the thing that you most recently saw with a call on next. So think about that. So, maybe we can take a look at this little list right here as an example. Suppose that I had called next, and suppose I had called next right here. So position had been 0, 1, 2, position had been 2, and then we called next and it returned what was here, and then position was incremented to be here. So if I say remove, position is position now one beyond where I return something. So the thing that I want to remove is one behind where position is right now. So what I'm going to want to do here is I'm going to want to say list.remove at position -1. Because remember, I mean, we did a position ++. You know, we moved position forward. And so we know that the thing we want to remove is one behind where we are right now. So we would remove at position -1, and then everything gets shifted down. And since everything gets shifted down, we're going to want to say position -. We're going to want to shift our position down by 1 because we're back on that prior spot because we've removed something from the list. Probably the trickiest thing with the iterator is that I had mentioned that you're not allowed to call remove 2 times in a row. You're not allowed to remove backwards by 2. You're only allowed to remove the most recent thing. So how do we get this thing to recognize that sometimes we don't want to let it remove things? We want to be able to have some kind of a test here that would throw some exception. You know, that if you're not supposed to be calling remove right now. And there's lots of ideas that people have about this. The people tend to realize that the iterator is going to have to remember whether it's okay to remove something or not. So we want an extra field, private Boolean remove okay. And then what's the manipulation on that? Is it okay to remove initially? No, it's not okay to remove initially because you haven't called next. So remove okay would be set to false here. And if and this is going to allow us to say if it's not okay, you know, to do the remove, if not remove okay. Remember, you don't want to do the equals false. You know, that would be a violation of Boolean Zen. We want to use the negation operator there. And if we've done a call on remove, then remove okay should be set to false here so that we don't allow 2 in a row. If it's not okay, we throw an exception. When does it get turned back to true? It gets turned back to true when we call next again. Then remove okay would become true again. So once we call next, there is something to remove, and that's what we would do. So we've pretty much covered, you know, the ideas behind the iterator. I'm going to post a complete version of this for today. Here's what it looks like. So it's got those fields that I mentioned. It's got an extra test in here that if you're calling next when it doesn't have a next, it throws a no such element exception. Here's the remove okay. It throws an illegal state exception. That's, you know, the iterator is not in a state where you're allowed to be calling remove an extra time. So this is kind of the code that we end up writing. How is it that we get an iterator? Remember that we ask the object. So like, well, we were doing it up here when we were doing an array list, is that we ask the array list for its iterator. So we're going to want to have a method in our arrayIntList class that returns an iterator. So it's going to construct a new arrayIntList iterator object. And what's it going to be iterating over? So if I ask you to make an iterator that can iterate over you, how do you know how to do that? Let me show you what's in the arrayIntList for today. I think this is the code is down here. The way that we write the iterator method is that you're going to construct a new arrayIntList iterator that iterates over this. This is that keyword that's the implicit parameter. It's a way of saying me, the reference to me. Make a new arrayIntList iterator that iterates over me. That's how we implement the iterator interface. Let me mention 2 more ideas. The other improvement that I make in this final version is something that copies what we do with the array list. When this one runs out of capacity, it doubles the size of the array so that it has extra capacity. So this one has a method called ensure capacity. I've changed the check capacity to ensure. So it makes a bigger array and it copies things over when it runs out of space. And that's what the built-in array list does, is it makes a bigger array. The last thing I want to mention is, remember I'd said that removeAll was somewhat inefficient, you know, the one that we wrote for this. The thing that's inefficient is that it might do a lot of shifting. So I want you to think a little bit about, can you write a more efficient version of it that doesn't require potentially a lot of shifting? And the notes have a solution, and I'm going to include it in the code for today, but I'll leave that as kind of a puzzle if you wanted to work on that.